Discrete random variables, page 4. A person rolls a normal six-sided die and wins the number of euros shown on the face. So if they roll a 1, they get 1 euro. If they roll a 6, they get 6 euros. Find the expected return from one roll of the die. Remember when we talked about the expected result, e to the e, expected value x, expected value of the random variable x, and I actually gave that example. What is the expected roll from a six-sided dice? Well, you do 1 times the 1/6 probability of getting a 1, 2 times the 1/6 probability of getting a 2, etc. One easy way to do that on the calculator for SAT or for the IB exam, you could go to Stat Edit, and then you could fill 1, 2, 3, 4, 5, 6 in the first row, which is the result of the roll, and the probability of each one happening in the second. Normally what we put into L2 is the frequency of it happening, which is usually a whole number. But instead, we could put the probability of it happening. Calculator doesn't care. So I could put 1 divided by 6, enter, and it'll change it to a decimal. And it'll put 0.16667 for each one. It's 1/6 of each one happening. Then I could do stat calc 1var stats, fill in L1 and L2 for list and frequency list, press calculate, and it'll give me 3.5. That is the expected value of one roll of the device. So basically what that means is if you are getting the number of euros that are shown on the dice, on average you will get 3.5 euros on every game. Find the expected gain of the player if it costs 4 euros to play the game. Well, on each play you're expecting to get 3.5 back. If you pay 4 every time you play, that would mean that it's -4 plus positive 3.5, and so you would expect to lose 50 cents a game. So that the expected gain per game is 50 cents. Would you advise the person to play several games? No. Suppose it costs k euros to play the game. What value of k will result in a fair game? So that would mean that you win 3.5 on each game and you lose k because you're paying k each game. In order to be a fair game, it would have to be a 0 result for each game, break even. So k would equal to 3.5. That would be a break-even game if they charge 3.5 to play. What value of k will result in a profit being made by the vendor? Not by the player, by the vendor. So that would mean, we look at it from the point of view of the vendor. The vendor is getting k for each game, and then he loses 3.5 on average of each game. So we want that to be greater than 0 for it to be a profit. So that would mean k would be greater than 3.5, right? So in order for there to be a profit being made by the vendor, he would have to charge more than 3.5 per game. Okay. That was all just common sense, but it showed like how to use the formulas to figure it out. Number 11, a country exports crayfish to the overseas market. The buyers are prepared to pay high prices when the crayfish arrive still alive. If the random variable x is the number of deaths per dozen crayfish, the probability distribution for random variable x is given by this table. Find k. Okay, so first of all, whenever they have these problems, and they're always going to have these problems on the IB exam, basically the only principle you're going to use probably is that all the probabilities have to add up to 1, right? So that's not too hard, right? We just add up all these other probabilities that are not k, and we see what they are equal to. So 0.54 plus 0.26 is 8.8, right? Plus 0.15, which would be 0.95, plus 0.01, which would be 0.96, 0.97. So 0.97. So the whole thing besides k is 0.97. So k must be the complement of 0.97, which would be 3% or 0.03. Over a long period, what is the mean number of deaths per dozen crayfish? Okay, so this is the deaths per dozen crayfish. So like most of the time, 5 or less die, right? If we wanted to figure out the mean, we could put these into L1, and we put these into L2, and then we do one var stats, right? And that'll give us the probability. Basically what we're doing is we're multiplying these together, and we add them all up. That's what one var stats does. So why don't we do that? So I'm going to turn on the calculator. I'm going to go to stat edit. And then in the first column, I'm going to put 0, 1, 2, 3, 4, 5. Do I need to put in greater than 5? No, because the L1 value is 0, so it doesn't matter anyway, right? And then I'm going to type these in, and K is 0.03, remember, and I'm going to type those into L2, and then I'll be back in a second. Okay, I filled in my table, and then I'm going to do one var stats. And my expected value is 0.74. So that means I'm expecting 0.74 deaths per dozen crayfish on each shipment. Less than 1. 13. A pair of dice is rolled, and the random variable m is the larger of the two numbers that are shown uppermost, or the value of a single die if a double is thrown. In table form, obtain the probability distribution of m and then find the mean of the m distribution. I think this is like a case like before, where it's helpful to draw a table like this one, with the top and the side showing the face of the two rolled dice. Right? I didn't leave very much space for you. Okay, so basically the high number is the result. So for example, whenever you roll a 6, then the result is 6. Whenever you roll a 5, except for when you roll a 6, the high is 5. And so on. You can see it makes a very nice little pattern here, doesn't it? Okay, so if I was to make a probability distribution of this, it would be the possibilities are 1, 2, 3, 4, 5, 6, right? And the probability of getting a 1 is 1 out of 36, right? Probability of getting a 2 is 3 out of 36. The probability of getting a 3 is 1, 2, 3, 4, 5 out of 36. 4 would be 7 out of 36. You're starting to see the pattern here. 5 would be 1, 2, 3, 4, 5, 9 out of 36. And the probability of getting a 6 is 11 out of 36. Very nice pattern. 1, 3, 5, 7, 9, 11. And if you add up 1, 3, 5, 7, 9, 11, you should get 36. 4, 9, 18, 29. Yeah, 36. So perfect. So this is the M distribution. So the probability of M. Okay, so that was part A. Part B says find the mean of the distribution. So now what we're going to do is we're going to put this into L1 and L2 in the calculator and add them all up, find the average. So that would be stat edit. And so on the left, we're going to put 1, 2, 3, 4, 5, 6. And I'm going to type this in, and then I'm going to come back. Okay, put the data and the probabilities in here, and then I'm going to do stat calc 1 var stats. L1, L2, calculate. So my mean would be 4.47. How would you do this manually? You would just do 1 times 1 over 36 plus 2 times 3 over 36, remember? 3 times 5 over 36, and so on. So if you ever get one where, like, instead of 7 out of 36, maybe you have a K here, well, that wouldn't happen, but maybe like here you have like a K, right? How can you figure out what this 4 is? You could do this and put the K in your formula, and then you could figure it out backwards, right? So like any one of these problems could be an algebra problem If you were going to do it as an algebra problem, you would either do guessing on the calculator or you would use algebra. 23D. Probability distribution is applied to sampling with replacement. So remember before we did some problems where we didn't have replacement and we cannot use our calculator easily to do those in a flash like we're going to do now. So like whenever you have with replacement, it means that you have like repeated trials that are exactly the same. The probability never changes, and that's super convenient to do to use the calculator function to solve huge problems. Random variable x is the total number of successes in n trials. We'll see this with the calculator. Probability of success is constant and is denoted by lowercase b. The probability of failure, of course, is the opposite, so it would be 1 minus b, 100% minus b. For the blue spinner in the book, and I drew a little picture here so that you can see what the spinner looks like, even if you don't open up the book. So if you have a spinner where 75% of the region is blue, what is the probability that you get a blue spin? It would be 0.75, right? And the probability you get a white spin is 0.25, right? So the p-value is 0.75 in this case. What is the probability if you spin 3 times? If you spin 3 times, what is the probability that you get 0 blue spins? What is the probability that you get 1 blue spin? What is the probability that you get 2 blue spins? And what is the probability that you get 3 blue spins? Okay, well, let's start with the 3 blue spins because that I think is easier. If you got 3 blue spins, that means you had a 0.75 chance on the first one, 0.75 chance on the second one, 0.75 chance on the third one, right? So that means that you got 0.75 times itself 3 times, right? So that would be the probability to get 3 blue spins. What about 3 white spins? That's also pretty easy. You would do 0.25, which is the opposite of 0.75, also multiplied 3 times. What about the probability to get 1 blue spin? The probability to get 1 blue spin would basically be 0.75 for the 1 time you got blue, 0.25 squared for the 2 times that you got white. And remember, there's 3 different ways that can happen, right? You could get blue, white, white, you get white, blue, white, or white, white, blue. So since there's 3 different ways that can happen, you multiply it times 3. For 2 blue spins, that would be 0.75 squared because that's 2 times you got blue, and there's 1 time you got white, which would be the 0.25. 3 ways of that happening too, so you multiply it times 3. Okay? So remember, like we saw in the investigation, this creates basically a Pascal's triangle pattern, 1, 3, 3, 1, and the probabilities are basically, you know, the number of times that you have success, right? So the 2 here appears here, and this would be the n minus p. So like 3 minus 2 would be the other exponent. And this is just like binomial expansion, which gives us the name binomial distribution, right? Just a review of binomial expansion. Expand p plus q to the 4th. Remember that Pascal's triangle coefficients for row 4 is 1, 4, 6, 4, 1. So that would give us 1, 4, 6, 4, 1. And then we could put p to the 4th, p cubed, p squared, p to the 1st, and p to the 0. And then we could put q to the 0, q to the 1, q to the 2, q to the 3, and q to the 4. And we just add all those together. And then, of course, q to the 0 is just 1, so I'll just erase that. So there's my expansion. If a coin is tossed 4 times, what is the probability of getting 3 heads? So if you toss a coin 4 times, that would be n equals 4. So we would be using a version of this distribution. What is the probability of getting 3 heads? 3 heads would correspond to 3 successes. 3 successes would be p cubed. So it's actually this one we're looking at. So it's 4p cubed q. So the 4 coefficient is because there are 4 ways of getting 3 heads in 4 tries, right? We can talk about that later if you want to. And the p is the success rate of getting 3 heads. So isn't the success of getting 1 head 1/2? And the probability of getting tails on the other one is also 1/2. So there we go. Okay, 1/2 cubed times 1/2. So the q is actually 1 minus p, but in this case it's kind of confusing because p is 1/2, so q is also 1/2. All right. So 4 over 2 to the 4th is equal to 4 over 16. Okay. Now expand this mess. Okay, so this is going to be the exact same thing. We're going to start with Pascal's triangle coefficient, and then we're going to put in the p-value to the 4th, the p-value to the 3rd, p-value squared, p-value to the 1st, and then that's it. And then the q-value is the complement of the p-value, so it'll be 1/3 to the 0, 1/3 to the 1st, 1/3 squared, 1/3 to the 3rd, and 1/3 to the 4th. Okay. 4 chocolates are selected at random with replacement from a box which contains strawberry creams and almond centers in the ratio 2 to 1. Find the probability of getting all strawberry creams. So the probability of getting a strawberry cream is 2/3. The probability of getting an almond center is 1/3. Find the probability of getting all strawberry creams. That would be this one. 4 successes, strawberry creams, 0 failures. 2 of each type would be this one. And at least 2 strawberry creams would be these 3 added together. Okay, so for the first one, it would be 2 to the 4th over 3 to the 4th. Right? That would be 16 divided by 81. And this one would be 6 times 4 on top, 81 on bottom. So that would be 24 over 81. So that would be the answer for part 2. And part 3, I would want to add this one, I would want to add this one, and I would want to add this one. This one here would be 4 times 8 on top, and then 81 on the bottom, so that would be 32 over 81. So if I added all 3 of these to get this answer, it would be 16 plus 32 plus 24. That would be 56, 66, 72 over 81. Okay, so the answer for the second one, this is the answer for the first one. And that's it.